Today, I'm going to teach you how to write a recursive rule for a quadratic function, and that starts now. Hello, ladies and gentlemen. Welcome back. Glad you could make it. Welcome to our channel. I'm Mr. Thompson, and it's our job to show you that bow ties are cool and math is fun. Today, we're going to be looking at writing a recursive rule for a quadratic equation. So the scenario for the problem plays out something like this. My friend Penelope has challenged me to doing pull-ups. And what she has said is, she said, "Hey, Mr. Thompson, I know I can start with 4 pull-ups, and then every day I can increase that number of pull-ups by 3. Okay, Penelope. So we go ahead and we label Penelope's work. We build out our chart of day 1, 4 push-ups. Day 2, 3 more at 7. Day 3, 3 more at 10. Day 4, 3 more at 13. We can see that this function is going to be a linear expression. This is going to be a linear function, and we're increasing by a constant rate of change each time we're adding 3. So our recursive rule for this linear function, our recursive rule, f of 1 is going to be 4 push-ups on the first day. F of x is going to be equal to f of x minus 1, our previous output, plus 3. Next thing we're going to do is we're going to look at how do we write the explicit rule for this linear function. I know I introduced this video saying quadratic, and here I am giving you linears. We need to build this as part of our background. We see that our rate of change here is constant, our constant rate of change of 3. So with our constant rate of change being 3, I'm going to see, is there a relationship between that 3 and my day number? So I look at day 1, there's 1 group of 3. I look at day 2, 2 groups of 3. Day 3, 3 groups of 3. Day 4, 4 groups of 3. My constant rate of change. And then I notice at the top of each column, there's 1 left over. That's going to be my y-intercept, my b term. So my explicit rule in this case is going to be f of x equals 3x plus 1. So Penelope and I were doing this contest for a couple of days, and Penelope was really getting excited about this, and then she really wanted to start to brag about just how many push-ups she had done total. I'm sorry, I said push-ups, I meant pull-ups. How many pull-ups had she done total? So the first day she can say, okay, I've done 4. Second day, 4 plus the 7 that she did that day, so now she said, I've done 11. Next one, 4 plus 7 plus the 10 on day 3, 21 pull-ups total so far. So what we want to do is be able to model how many pull-ups has Penelope done each day. I'm sorry, not each day. How many pull-ups has Penelope done total in our time that we're tracking, this little contest? So the first thing I'm going to do is write a recursive rule. So to write this recursive rule, I start at f of 1 equals 4. Then, what I notice looking at this illustration, I see that each day adds the total, the amount of that particular day. So what we're going to do is we're going to take the previous total and add that particular day. Well, we found out from our explicit rule what that particular day would be. So for instance, day 4, 3x plus 1, that's the equation of our explicit rule for our linear expression for that day. So we had the total plus day 4. 4 times 3 is 12, plus 1 is 13. Day 4, we're adding 13 to our total to get up to our 34 total pull-ups for that day. Based on looking at our image, we can see that we're adding just that linear piece. Let's try that again. We're adding the day's total, and we can find that day's total by using our explicit linear expression. Next thing we're going to do is we're going to take and look at how do we write this recursive rule when we don't have a visual representation. We don't have the chart. All we have is a table of values. So we'll go ahead and we'll build our table of values, X being days, Y being our number of pull-ups. So 1, 4, 2, 11, 3, 21, 4, 34. We're doing our total because we want to do a recursive rule for our total number of push-ups completed. And here's how we figure out that this is quadratic. We start and we do our first difference. And we notice that the first difference in each one of those is different. So we know this expression isn't linear. I go to my second difference and I look here and I see that my second difference is 3. My second difference is a constant. If your second difference is constant, that tells you that your expression is quadratic. Linear first difference, constant second difference represents a quadratic function. Linear first difference, constant second difference represents a quadratic function. So we know our first difference is linear, we know our second difference is constant. We're set up to be a quadratic function. Now, to write the recursive rule in this case, obviously our recursive rule starts with f of 1 equals 4, our starting value. Remember, we're doing the recursive rule for the quadratic function, the total number of pull-ups done on each particular day. From our visual model, we said that we took the previous and added the linear expression of that day. That's exactly what we're going to do here. We're going to say f of x is equal to f of x minus 1, our previous term, plus the linear first difference. So whatever the equation is of that linear first difference. We've already figured it out in the table with we figured it out using the chart and the visuals. Now, let's figure it out using the algebra. Penelope and her pull-ups. We now have a table of values. I'm going to find my first difference. 7, 10, 13. And then what I'm going to do is I'm going to figure out, okay, what is my second difference? My second difference at constant rate of change, that's going to be the slope. Constant rate of change here in the second difference, that's going to be the slope of my linear first difference. And that linear first difference, we're going to have to write that in terms of y equals mx plus b. Write that in slope-intercept form. Well, I don't know what my b term is. So I'm trying to figure out the relationship. What's the relationship between the input, the day number, and the first difference? So to day 2, to get into day 2, we have a first difference of 7. To get into day 2, I'm not looking for the output, not looking for the total number, not looking for the total number of pull-ups. I'm looking for the relationship between the input and the first difference. That's going to show me 7. So I substitute that into slope-intercept form. Substitute in 7 equals 3 times our x value, in this case is going to be 2, our input, plus b. That works out and shows me that my b term is 1. So writing that in slope-intercept form, the linear expression there is y equals 3x plus 1. So when I take that and put it into my recursive formula, put that into my recursive formula, f of 1 equals 4, f of x equals f of x minus 1 plus that linear first difference, 3x plus 1. Ladies and gentlemen, thank you for sticking with us all the way to the end. If you've made it this far, go ahead and smash that like button. Let the YouTube algorithm know that this is some good stuff. Hey, speaking of good stuff, let's go ahead and recap what we did today. We found our recursive rule for our linear expression of each individual day. We then took that, we made the explicit rule for the individual day. Then, as a total, knowing that the total is going to be quadratic, we needed to know what that linear explicit rule was to be able to write the recursive function of the quadratic formula, of the quadratic equation, making sure that we knew what that linear first difference was. As always, I hope you have a fantastic rest of your day, and I'll see you on the next one.